So now I'm going to move on to the lecture 9, perfectly competitive equilibrium. So this is like one of my favorite lectures because it's starting to put all of the pieces to the puzzle together, right? So things that we've studied, right? Just to remind ourselves where we are in the class, right? We started with preferences in the beginning of the class and budget constraints. Right, and then we solved for individual demand, right? The demand for like one person. And then we started with like production functions. Right, and then we use those to solve for cost functions. Right, and then firm supply. Okay, and in this lecture, right, what we're going to do is we're going to then aggregate up from individual demand to aggregate demand or market demand. And from firm supply to aggregate supply. Right, so one of the really fun things that I think in this in this class is that we see sort of lots and lots of pieces come together, and we could change any part of this. We could change the wage rate, or we could change somebody's preferences for good X, or we could change their preferences for good Y, and we could see how this affects everything. Right, and then we're going to put these together, right, to get like a market equilibrium. Right, and so what is like the eventual price and quantity that good X would sell at? And we could change any piece of this and see how that's going to change the equilibrium. So this is, I don't know, this is a lecture I get really excited about because it's us finally putting together all of the pieces of the puzzle and sort of seeing where this goes. So the first thing that I'm going to do in this lecture is just briefly talk about how we go from individual demand to aggregate or market demand, and how we go from firm supply to aggregate supply. Okay. And this is something that a lot of students forget. I think it's a very trivial step, or it's going to feel like a very trivial step. And so it's one that students, like this is one of the more common mistakes that people will make. And it just kind of gets really messy. It's one of those mistakes that's actually surprisingly hard for us to clean up with like partial credit. So don't forget to do this step. Right, if you're trying to like solve for market equilibrium, but only are thinking about, say, one person buying a product from 50 firms, right, your answer is going to be weird. So how do we think about aggregate demand, or how do we, say, get market demand, right, from individual demand? Right, and all we're going to do is just add up the demands from each consumer. Okay, that's really all it is. So, this is usually one of those like times in the class where I'll like pick on people's names, but that feels weird to do over video. But just take 3 people in the class, and if you want to know what their demand is, well, for a given price, just ask them how much they demand and then add their 3 answers up, okay? So the way that this works And I'm going to use uppercase for aggregate or market demand. So let's say we just have like 2 people for now. Right. Let's say that person 1, if their price is, let's say when P is equal to 5, person 1's demand is, let's say, 3, and person 2's demand is 2. And when price is 6, right, person 1's demand is 2, and person 2's demand is also 2. Okay? And then if we want to just figure out, well, what's the demand for those 2 people, let's just add that up, right? So aggregate demand, QD, is going to be 5 and 4, right? So we're just adding up individual demand curves, okay? Just as a note, I'm going to use capital letters here for aggregate demand and supply. Yeah. So this is, these little lowercase q's, right? This is the Marshallian demands that we solved for before midterm 1 or on midterm 1, right? And we're just going to add them up, right, in order to get aggregate demand. And we're going to do that for every consumer that we have in the market. So if there are M consumers in the market, we're just going to add over all M of them, okay? Now, an assumption that we're going to make just to make our lives easier, right, is let's just say that all consumers have the same demand. Right, then what we can do is just, if there are M consumers, we can just multiply an individual demand, right, by M. And that will tell us market demand, right? If there are M people who all, have this particular demand curve, right, we just have to multiply their demand curve by M to figure out what aggregate demand is. Okay, I'm going to turn to aggregate supply, and I'm going to turn the page. So if you want to pause for a second, you should do that if you're still copying things down. Okay, so supply works in very much the same way. So aggregate or market supply is just the sum of individual supply curves, which we dealt with, or we solved for in the end of the last lecture, like lecture 8.4, 8.5. And again, if we have n firms, right, we just sum up over all of the n firms, right, supplying that good. All right. So, and again, right, we can make the assumption that if there are n firms and all of the firms have the same demand, then we can just multiply by n. Or sorry, if all the firms have the same supply. So if all n firms have the same supply, right, we can just multiply. Now, I guess I should say, right, so both with supply and demand, right, this is much more general, right? So it's not uncommon, like for the stuff that I do for my research, to have different types of consumers that we sum over, and then you have to do more complicated math. Or you could have, different types of firms, like you could have big firms and small firms, right? You could have Little Italy competing with, Domino's and Papa John's, and they might have very different supply curves, right? In which case you would want to do something a little bit more fancy. I don't think that that's really the point of this class, so we're just going to think of each firm, at least not now. I think in the price discrimination notes we will have differentiated consumers, but for now we're just going to think of just a bunch of individual firms and a bunch of individual consumers that all have the same supply and demand curves. Okay, so from there, like I said in the last page, what we're going to be doing, right, is we want to put this together to get equilibrium, so get an equilibrium price. And so what is an equilibrium? So an equilibrium, or what I'm going to call a partial equilibrium, and I'll talk about why I'm calling it that in a minute, is going to it's going to be characterized by three things. So first, firms are going to be maximizing profit. Second, right, consumers are going to be maximizing utility. Right, and then finally, right, markets clear. Okay, so let me talk about each one of these things, right? So firms maximizing profit, right? This is what we did, right, in lectures 7 and 8. Right, first they found the optimal amount of capital and labor to purchase, right? That was lecture 7, cost minimization. And in lecture 8, right, they were maximizing profit, right, in order to get the individual firm supply. So when we write down, right, our aggregate supply curve, right, implicitly firms are maximizing their profit when we do that, right? Each firm is maximizing profit when they do that implicitly because we know their supply curve, right? Their supply curve is a profit maximization, it's the solution to a profit maximization problem, right? Same with consumers, right? In lecture 3, right, firms were maximizing consumers were maximizing their utility, and that's how we got individual demand curves, right? And then when we get market demand curves, it's just the sum of a bunch of consumers maximizing their utility, all right? This final thing, markets clear, right, just says, right, that market supply equals market demand. Okay, so what that's saying, like in practice, right, is that when firms are maximizing their maximizing their profit and consumers are maximizing their utility, right, we also need them to be able to purchase enough and sell all of the goods that they make, right? So each consumer can get what they want, and firms are able to sell all that they produce. Otherwise, like, one of them wouldn't actually be maximizing, right? So we also need supply to equal demand, right? When that happens, right, everyone is maximizing at the same time, and so no one wants to change the outcome of the market. And that's why we call it an equilibrium. So I'm going to write here, everyone is doing optimal things, which is why we call this an equilibrium. All right, and the beauty of economics, and something I'll talk about later, right, is that, well, what's the thing that's moving in all of these, right? It's the price, right? So the supply curve is a function of price, the demand curve is a function of price, and in order to equate supply and demand, what we're going to do is we're going to change the price. So we're going to have, or I'm going to use, P star is called an equilibrium price. If it gets all three of these conditions to hold. Right, and sort of in the way that we've been, so let me go back and just talk briefly about why I use the term partial equilibrium here, right? So at the moment, right, there are actually lots of markets that we've been thinking about. So let me actually just write why partial equilibrium first. So in theory, we've discussed lots of markets or lots of goods or products. Right, so like we have good, good X, good Y. Firms are selling, or purchasing capital, they're purchasing labor, right? Lots of different things that are happening or being purchased or in our model so far. And the idea here, right, is when we have, supply equal demand, we're doing that for like one product. So I'm calling it Q, but maybe we could think of this as product X. Right, this is sort of one of the places in this class the notation gets a little bit weird. We've changed from an X to a Q, right? But all I'm saying is that there's a price, or when we find an equilibrium price in this class, we're finding a partial equilibrium price because we're only making sure that prices, or that the market clears for good X. We aren't thinking at all about whether or not the market for good Y or K or L clear. So if you take a macro class, they'll think of something called a general equilibrium. I think this will also come about in a public class, but this says all markets clear. And it's like going to be a set of prices where every single market is in equilibrium at once. We don't worry about that as much in this class. We just are focusing on one market, hence a partial equilibrium and not a general equilibrium. All right, so let's put all the pieces from the last video together. So the goal here is going to be, I'm going to give us a demand curve and a supply curve, and we're going to find a market equilibrium. So I'm going to start, let's start us though with finding, with like an individual demand curve. So we're going to have 100 consumers with each one has a demand curve, individual demand. Of 10 minus P. And then we're going to have 10 firms each with a cost curve. So I'm going to use a short run cost curve because this is a short run problem. I'm using the problem from the last lecture of q squared over 20 plus 125. And as we saw in lecture 8, when we have this short run cost curve, we get a supply curve then, individual firm supply curve, or for firm J of 10p. All right, so we'll get to finding equilibrium price and quantity, but first we need to do that first step, right, which is let's find market price, or market demand and market supply. Right, and recall all that we have to do, right, is we just have to sum up over all of the individual demands and all of the individual supplies. Okay. So for market demand, right, aggregate demand, I'm going to use capital D as a function of P is equal to the sum of all of the demands for each consumer. Okay, or in this case, because each consumer has the same demand curve, there are just 100 consumers who all have the demand 10 minus P. So we just have 100 of them, or 1,000 minus 100P is the demand curve. Okay, and let me leave a little space for us to draw, to solve for the supply curve, but let me graph out the demand curve first. So on a graph with quantity and price, right, we have a demand curve that is 1,000 minus 100p. All right, so something like that is our demand curve. To get supply, we do the same thing. We're just going to add over all of the supply, all over the individual firm supply curves. So QSP is equal to their 10 firms times individual supply of 10p, right, or 100p. All right, so this is what that looks like. It starts at the origin, it goes up. So supply is 100p. All right. So now, so this is how we found aggregate supply and demand. All right, now what we want to do is find the equilibrium price. And I'm just going to say, like, that's part 1, aggregate quantity. And then say the amount each firm produces. And then finally, each firm's profits. Okay. So to find the equilibrium price, all we're going to do is just set supply equal to demand and solve for P. All right. And what that's doing graphically, right, is it's finding this point where the quantity supply is equal to quantity demand. And then when we solve for P, right, we're finding this coordinate here, the P coordinate. All right. So what we're going to do, right, QD P is equal to QS P. Now let's take our results from here. Right, so 1,000 minus 100p is equal to 100p, right? And then let's solve for p. So we have 1000 is equal to 200p, or p star is equal to 5. Okay, so again, right, we're just taking this function and figuring out when they're equal to each other, right? When are they supplying the same amount of quantity, like at what price? And that price turns out to be 5. Okay. So from there, what we're going to do is let's solve for aggregate quantity. Okay. For this, you can use either the supplier demand curve, right? We know this coordinate, we just need to find this coordinate, but because they're equal, right, they should give us the same answer. So I'm just going to use supply here. So just plugging in QS of 5 is equal to 100 times 5, which is equal to 500. All right, and we can do this for demand, right? So QD of 5 is equal to 1000 minus 100 times 5, or again, 500, right? This should give us the same answer. So Q star is equal to 500. Okay. So now let's find how much does each firm produce. Well, this is pretty straightforward. So this was part 3, I guess, or question 3. This was, I should have handled these better at the beginning, but anyway. So how much does each firm produce? Well, total output is 500, and there are 10 firms. Okay, so firm-specific supply is equal to aggregate supply divided by the number of firms. So 500 divided by 10, which is equal to 50. You could have also, right, taken the individual supply curve, individual firm supply curve, and plugged in price. You'd have gotten the same thing, that each firm is producing 50 units of output. So either way works. All right. And then what is each firm's profit? Okay, so just recall that for this is the last question I ask. Profit is always equal to revenue, which is P times Q, right, minus cost, which in this case was given as Q squared over 20 plus, minus 125. Right? We need to just remember, use the firm level quantity here. All right, and just plugging in what we know, this becomes 50, or 5 times 50, right? 50 from here, 5 from here, minus 50 squared over 20 minus 125. All right. If you plug this into your calculator, you'll see that this is equal to 0. All right. So the firm is making no profit, but that's fine, right? We saw in the last lecture firms could even have negative profit. The firm's revenue, right, 250, is higher than their variable cost, 125. So they won't shut down. So now I'm going to talk about producer and consumer surplus, so page 3 to page 6 of lecture 9. And just to motivate this a little bit, in the next video we're going to think about what happens when price changes. So like what happens if there's a tax or something? How can we evaluate the impact of a tax? So let's say right now, without thinking about why prices changed, Let's just say that the price of X uh, changes from px naught to px1. All right. How should we measure like the welfare impact of that? And probably the like naive way or sort of the first way that you think about doing that, right, is let's measure the change from like the utility at the price P naught to the utility at the price U1, right? So, we know how to solve out for what demand would be, and then we can plug that demand, X star and Y star into our utility function, right? And we can see the change in utility. All right, why might this not be a good measure? Like, why wouldn't we want to use the change in utility, right? Because we could do this, right? I mean, you have the skills, right? If we knew what demand looked like, right, we could figure out what the change in utility is, right? Or if we knew what the utility function looked like, we could figure out what the utility function is, right? So the problem, right, is that utility is ordinal. Right? So if like I didn't say want the tax to pass, right? What I would do is I would say, oh, well, let's just like multiply utility by 100, right? So it looks like there's going to be this huge change in utility when the prices change. Or if I wanted it to pass, I'd say, well, let's multiply, utility by 1% or something, and make it really, really small, so that the prices are going to change, but that's not going to change utility by very much, right? Utility, as we saw, or at least utility is ordinal. The form of the function matters. So like we could have two utility functions, v and u, where v is 100 times as big as u, that they both represent the same preferences. And so I can't actually tell, in the data whether or not people are using u or v, right, as their utility function, right, because they're still making the exact same choices that they would otherwise, right? It's just, with utility function v, it looks like they care a lot more, right? So to get around this problem, instead we're going to use this idea of consumer surplus. Which is the difference between like what consumers are willing to pay and what they actually have to pay. All right, so consumer surplus, the difference between what consumers are willing to pay and what they actually pay. Technically, this is just the area under the Marshallian demand curve and above the price. Sorry, below the Marshallian demand curve. Okay, so let me just give an example here or draw out a graph. So say we're in a world where we're, say, I don't know, I think in the notes, I have a shopping for t-shirts. So if we ever get to go outside and see our friends again, you know, it'd be nice to have like a new wardrobe where we can wear new clothes. And let's say that the price of a shirt is like $10 at the store. Okay. So this is the actual, you know, this is the price that you actually have to pay at the store. This is what's on the tag. All right, but let's say that you value, say, the first shirt at like 20, okay? And, you know, maybe you value this, or you'd be willing to pay $20 for that first shirt, right? And so the difference between what you pay, right, and what you're willing to pay is your surplus, right? This is $10 of surplus because you'd be willing to pay 20. You only had to pay 10, right? If they were to say charge $20 for it and then give you $10 back, right? You'd be just as well off as if they just charge $10 for it, right? And so that's like $20 like back in your pocket because you were willing to pay 20 for it. All right. So that would be, you know, for this one unit, that would be, you know, $10 of consumer surplus. Let's say for the second shirt, right, you were willing to pay 18, right? And then for the third shirt, maybe you're willing to pay 16. And the fourth, 14, and like the fifth, 12. Okay? And so again, right, so this, as you can see, is basically mapping out your demand curve, right? At a price of 20, you're willing to buy 1. At a price of 18, you're willing to buy 2. At a price of 16, you're willing to buy 3. At a price of 14, you're willing to buy 4, right? But also, the area between your demand curve and the price is your consumer surplus, right? So for this one, you get $10 of surplus. For this one, you got $8 of surplus. You're willing to pay 18. You only have to pay 10. For the third one, you get $6 of surplus all the way down to 0, right? So again, like consumer surplus, just the area under the demand curve, right? And we're just going to sum these up. So in this case, right, consumer surplus, right, is 10 plus 8 plus 6 plus 4 plus 2, which is equal to 30. Okay. So producer surplus is basically the same idea. It's just the area above the supply curve and below the price level. Right, so recall, right, for a firm that the marginal cost curve, right, or the firm supply curve is the marginal cost curve. So if we have a firm, say they're producing shirts and they sell, you know, or it costs they're willing in perfect competition, that first shirt, they're willing to pay, they're willing to sell one shirt at a price of $2, right? And maybe they're willing to sell 2 shirts at a price of $4, and the price is ultimately $10, right? Well, the idea, right, is, you know, the supply curve is telling you exactly that. They're willing to supply 1 shirt at $2, right? The supply curve being their marginal cost curve, which we saw in the previous couple lectures, right? Which means that it cost them $2 to produce that shirt, right? Which means that their producer surplus is $8, right? It's the difference between their cost of production, right? Their marginal cost of production and the cost and the price that they get for that shirt. For the second shirt, if it costs, say, $4 to produce, right, then they get $6 because they sell it for 10, and it only costs 4 to produce. And so again, with producer surplus, we're going to add up, we're going to sum up all of the area underneath or above the supply curve and below the price level. All right. So I'm going to change pages now. So if you want to pause for a second and make sure that you've written everything down, go for it. All right. So what we want to do is find now producer and consumer surplus. Okay, and here, so typically, like, we would do this with integrals if there was a calculus requirement in this class. But I'm going to simplify this because I think most of us have not seen integrals. And so for the rest of this class, demand and supply curves will be linear. I don't know that it's really my place to teach integration, and this is the one place we would use it, and so I don't know that it's worth the payoff. So the one thing, math to remember here is the formula for the area of the area of a triangle. Which is 1/2 base times height. All right, so that's just when we find consumer and producer surplus, we're going to be finding triangles or areas of triangles. So I'm going to use the numbers from the last video, or the sort of our running example, to go through and show you how we do this. So from last lecture. So you may already have these numbers in your notes and this graph in your notes. So we had a supply curve that was QS is equal to 100p. We had a demand curve that was 1000 minus 100p. And this led to equilibrium quantity of 500 and an equilibrium price of 5. Okay. So let's start off. Let's find consumer surplus. Okay. So again, right, consumer surplus is the area below the Marshallian demand curve and above the price. So it's this area here in blue, right, above price and below Marshallian demand, right? That's consumer surplus. Okay, so we just need to find the area of this triangle. All right. What is the okay, so what is the base? All right, well, the base of this triangle is just 500, right? This is just going from 0 to 500, the quantity consumed. All right, height is a little bit trickier, right? So height Right, we need to find the p-intercept, right? We need to find this point here. Where does the demand curve hit the p-intercept? Okay, and that's the point where Q is equal to 0. Or quantity demanded is equal to 0. So at what price is quantity demanded equal to 0? Well, we can just plug in 0 for demand into our demand curve. All right, and so we get 0 is equal to 1,000 minus 100p, or p, I'm going to call this p int, is equal to 10. All right, so the p-intercept is equal to 10. All right, and now we know the height, right? The height is 10 minus 5, right? At 10, nobody purchases. At 5, 5 is the actual price level. And so this is the height of the triangle. All right, and so consumer surplus is equal to 1/2 base, which is 500, times height, which is 5, which is 1250. All right. For producer surplus, it's the same idea. We just need to find now the area of this triangle here, right? The area between the supply curve and the price. Okay. So again, right, what is the base of this curve? Well, it's just, again, or the base of this triangle, it's just from 0 to 500. So the base is 500. Again, we need to find the height, and the height is a little bit trickier because we need to find the p-intercept, this time of the supply curve. Height. Right, so we're going to plug in 0 is equal to 100p, right? Just plugging in 0 for the quantity supplied, because that's going to tell us what the p-intercept is, and then find what value of p gets us there. So p int now is equal to 0, and so we know that the height is equal to 5 minus 0. The height of this triangle is 5. And so the producer surplus is equal to the base, which is 500, times the height, which is 5, times 1/2, which is again equal to 1250. Okay. So one more just point that, or question that I often get and want to clarify, which is the difference between profit and producer surplus. Right, so in the last lecture we went through and we found that the profit in this for this example was 0 for each firm, right? But we're finding that producer surplus here is not 0 in the aggregate. So there's one difference, which is this was a firm profit versus this is aggregate producer surplus, and so there are 10 firms, so maybe each firm gets 125 units of producer surplus. But there's a more fundamental difference, which is that producer surplus doesn't take into account fixed costs. So when we calculated profit, and you might want to go back and look at your notes from the last lecture, right? We had, or from the last video, we had profit was revenue minus variable cost minus fixed costs. And producer surplus is just revenue minus variable costs. And how do we see that, right? That's maybe not something that's plainly obvious. Well, remember how I explained what producer surplus is, right? Producer surplus is the area basically above the marginal cost curve for each firm, right? Marginal costs, or marginal cost for basically each unit. So like the supply curve is telling us what the marginal cost is for the firm. Marginal costs do not account for fixed costs, right? And so when we do this exercise of like what's the difference between the price and the marginal cost, right, we're not accounting for the fixed cost that the firm has to pay, right? And so fixed costs are not in producer surplus. That's, I think, the way to sort of see the difference between the two. Okay. Now, if this were class, what we would do is hand out H09 perfectly competitive equilibrium .pdf. So if you want to take a look at that, the next video will be the solution key for that. All right, so now I'm going to go through the solutions to hand out H09 perfectly competitive equilibrium. So to start off, the first question in this handout asks us to find a market demand curve from individual demand curve, and the individual demand curve here is 25 minus 5p, and there are 40 consumers, and we're asked to find market demand. So how do we do that? Well, we're just going to multiply individual demand by the number of consumers. So QD is equal to 25 minus 5p, right, times 40. And so market demand is equal to 1,000 minus 200p. All right. So let me draw in a demand curve. Not at all to scale, but just to give us some idea. Let's say that this is QD is equal to 1,000 minus 200p. Okay. So then what it's going to ask us, it's going to give us the short run cost function and ask us to find individual firm supply and then aggregate supply. So the short run cost function is C of Q is equal to 250 plus Q squared over 50, right? And we want to find firm supply. All right, to do that, we're just going to write down the profit function, take the first order condition and solve for Q, right? Firms are profit maximizing. So profit is equal to revenue, which is price times quantity, minus cost, which is 250 minus Q squared over 50. All right, that's step one. Then we're going to take the first order condition, right, to maximize profit. Okay, so the derivative of profit with respect to Q is going to be P minus, there's no Q here, so this is a 0, minus 2Q over 50. And we're going to set that equal to 0 because we're taking a first order condition. Right, we're trying to find the max of the profit function where the slope of the profit function is equal to 0. Okay. So from there, then we're going to solve for Q. So P is equal to Q over 25, or Q is equal to 25P. All right, so this is for each individual firm, right? For every additional dollar of the market price, each firm will produce 25 more units of output. All right, so then 3 asks, if there are 20 firms, what is market supply? All right, and again, right, what we're going to do is we're just going to multiply the number of firms times the supply curve, or individual firm supply curve, which is 20 times 25P, which is equal to 500P. All right, and I'm just going to draw that up here. Again, not at all to scale, but QS is equal to 500P. All right. So now, all right, so for part 4, I do something that I sometimes do on exams just to make it so that it's easier to give partial credit, or like if you mess up on an earlier part, which I'm going to change the demand curve to QD is equal to 2000 minus 500P. So let me draw in that demand curve. Okay, and then we're going to use the same supply curve from before and the same cost curve, and it's first going to ask for the short run price, aggregate supply amount each firm produces, firm profit. So 1, all right, to find the short run price, right, what we want to do, right, we just want to find this coordinate, right? So what we're going to do is set quantity supply equal to quantity demand, which is saying that 500P, which is quantity supply, is equal to 2000 minus 500P. Adding 500P to both sides, we get 1000P is equal to 2000, or P star is equal to 2. All right, and so that's this coordinate here. All right, so the price is equal to 2. What is the quantity, right? That's what question 2 is asking. So again, we can plug the 2 into either 500P and get 1000, or we can plug it into 2000 into demand and get 2000 minus 1000P and get 1000. So either way, right, you can plug it into either one, and it should work. Q, I'm just going to do this with just supply for now, is equal to 1000 minus 2, which is equal to 1000, right? But either way, the quantity is 1000, okay? So then we want to find the amount that each firm produces, all right? And so from the last page here, there are 20 firms. They produce in total 1000 units. And so we can either do Q divided by N, which is 1000 divided by 20, which would be equal to 50. Right, we can plug into the each firm's supply curve, QS of P, which we found to be 25P, and since P is 2, we know that this is 50. So you just need one or the other, but either one works. I'm just going to circle this one, but either way should give you the same answer. And then finally, we want to find the profit for an individual firm. So for an individual firm, we know that their profit function is always price times quantity minus their cost, which in this case was 250 minus Q squared over 50. All right. So we're just going to plug in what we know. We know that the price is equal to 2. We know that the individual firm quantity is 50. Their costs are then 250 minus 50 squared over 50, right? The big problem, like when people mess this problem up, it's they forget to use individual firm quantity, not aggregate quantity. And then this is equal to, should be equal to negative 200. Okay, so again, firms here are not profitable, right? However, right, the firm's revenue is 100, right? The firm's variable cost is 50, just this section here, 50 squared over 50 is just 50, right? Their fixed cost is negative 250, so they're not profitable, but their revenue is higher than their variable cost. And so the firm wouldn't shut down, and so these firms would all produce. Which, you know, I think, yeah. Okay, so then the last part of this question asks us to find consumer and producer surplus. Okay, so recall that consumer surplus is the area above the price and below the Marshallian demand curve. So it's this area here. All right, we just need to find the area of that triangle. So for consumer surplus, right, the base is 1,000, right, just the quantity sold. And then again, for the height, we need to find the p-intercept. Right, because we need to figure out what this point here is. We can plug 0 into the demand curve. So this is 0 is equal to 2,000 minus 500p, or p int is equal to 4. Right? And so the height is 4 minus 2, which is 2. And so the consumer surplus is equal to 1,000 times 2, the height of this triangle, times 1/2, or 1,000. All right, for producer surplus, again, we want to find the area above the supply curve and below the price. That's this area here. In order to do that, we need to know the base, which is again 1,000. Right, and the height, we need to find the p-intercept. To do that, we can plug 0 in for supply. And get that the p-intercept here should be 0. That's this point here. So the height is also 2, or 2 minus 0. And so the producer surplus is equal to 1,000 times 2 times 1/2, which is equal to 1,000. All right, so in this video, I'm going to talk about efficiency and deadweight loss. This is page 6 of lecture 9. So let's think about a consumer who initially purchases some quantity of good X, let's say X naught, at a price P naught. Okay. And let's say then that there is a tax which raises the price to P1 and lowers quantity to x1. All right, so let me draw out that situation. So we have some quantity Q, we have a supply curve QS, a demand curve, original demand curve QD, right? And then some initial quantity X naught and an initial price P naught. All right, and then there's a tax which raises the price to P1. And the new quantity then is X1. Okay, so what I want to talk about for the next couple minutes is this point. There are two reasons why consumer surplus would fall. Okay, and we can see them in this graph. So the first reason is that the consumer is going to lose some surplus on each unit they still purchase, right? And so that's this area here. So they still purchase X1 units, so they're still purchasing all of these units here, right? But for each of those units, the price is a little bit higher, right? And so instead of getting the surplus from the demand curve or their willingness to pay to price P0, they only get the surplus to price P1. So they lose this much surplus for this reason, right? So reason one, consumers lose some surplus on each unit they still purchase. Because the price is higher on each unit. Right, so when they went to the store and they were willing to pay $20 and it cost 10, right? They got 10 units of surplus. When they went to the store and it cost 12, they only got 8 units of surplus. And so they lose a little bit of surplus just because the price is higher. But that's for the units that they still purchase. And I just want to note, right, that this amount, right, the difference between the $10 and $12 or P0 and P1, right, that's going back to the government in revenue. So someone still captures that surplus. Right, and so we might not think that this is such a big deal, right? The government, in theory, not that it does this, but it could sort of redistribute that money back to the consumer. And so the consumer might not be losing all that much, right, if they're getting some value from government services, right? Now, there's another form of consumer surplus loss. So there's another reason the consumer loses surplus, which is that they're now purchasing less. Right, and this is the difference here between X naught minus X1, right, or this area here, right? And the idea, right, or the issue or the thing that we worry about with this, right, is that this surplus isn't being captured by anybody. Right. These are trades that aren't made, right? Or these are purchases that aren't made. And so it's not like the government is getting tax revenue from these purchases like they were from these purchases. Okay, and what this means, or what this leads to, is deadweight loss. All right, this is the loss in total surplus that comes about because positive surplus trades that otherwise would have been made no longer happen. Right. So just to give an example of this, right? Suppose that we have a good that normally costs, or we have sort of a unit that costs $9.75 to produce. All right, let's say the willingness to pay for that unit is $10.25. All right, and the government imposes a $1 tax. Okay, well, the issue, right, is that there's 50 cents of surplus to be had here, right? The consumer is willing to pay 50 cents more than it costs to produce. So there's 50 cents of surplus that either the consumer or the producer could capture, right? If this sale happened, right? Somebody is better off by 50 cents. The problem is the tax is $1, right? And so this sale can't happen. Both the consumer and producer can't be better off, right? By making this trade, right? And so because this purchase then never happens, those 50 cents of possible surplus just disappear. Okay, and so that is sort of the efficiency loss that we worry about because it isn't captured by somebody, right? It's not recaptured by the government. It's just lost surplus. Okay, so let's do an example to show how to find the effects of a tax and how to calculate out deadweight loss. So we're going to use the example that we've been running through in the notes, where the quantity supply is 100p, the quantity demanded is 1000 minus 100p, and when we did that example, we found the price was equal to 5, and this quantity demanded was equal to 500. Okay, so in this example, we're just going to assume that the government imposes a $1 tax. First, we want to find the new price and quantity, and then we want to find the producer surplus, consumer surplus, tax revenue, and deadweight loss. Okay? So the first thing that we want to think about is, well, how do we think about imposing a tax in this model? All right? So let's think about what a tax does, right? And what a tax does is it creates what they call a wedge between what the consumer pays and what the store gets. Okay? So if you think about, like, there's a product and there's like a $1 tax, right? The store gets, let's say, well, the way that I like to do this is the store gets PS, so they get some, or the producer gets some price that's the producer price, and then the consumer, or you, pays the tax plus the price that goes to the producer. So the price that you pay at the store is equal to PS plus T, the tax, right? So if the price that the store gets is like $3 and the tax is $1, you pay $4. Okay, and so I find it helps to sort of think about the price that you pay and the price that the store pays when you think about what happens to the supply and demand curve. Okay, so the supply curve, right, is a function of the price the store gets, right? And so it's still 100 times PS, right? Because the store, for the price that it pays, I need to make this subscript, for the price that it receives, right, it maximizes its profit. And the way that we did that is we just take the price that it gets, and we find the way that we find the supply curve is we take the profit maximizing quantity for that price, and it's just the price that the store receives. So nothing changes here, right? Same with the quantity demand. Nothing changes, but we have to think of quantity demand, right, as a function of the price that the consumer pays, right, which is which is PD. Okay, so quantity demand is a function of PD. Quantity supply is a function of PS. Now, the way, right, demand is a function of the price that the consumer pays. So the way that I like to think about this, right, is as before, what we're going to do is we're going to set quantity demand equal to quantity supply, but we need to deal with the fact that they have different prices, okay? So set QS PS, right, equal to QD PD, right? So we're going to set 1,000 or 100 PS is equal to 1,000 minus 100 PD. Okay, and then we know the difference between PD and PS, right? It's just PS plus T. So we're going to say that 100 PS is equal to 1,000 minus 100 times PS minus, and since T is 1, I'm just going to do 100 here, right? Or 900 minus 100 PS. Okay, so what I've done, right, is I've just changed this demand curve to be as a function of PS rather than a function of PD, right? And so the way that looks graphically is like that we're shifting down the demand curve by 100 units. Okay, so this new demand curve is 900 minus 100 P. Okay, but this is corresponding to the supply price. Okay, so now we have both supply and demand, right, accounted for in the supply price. Again, what we're trying to do is let's find the point where quantity demanded equals quantity supply. That's right here. So we need to find this coordinate here, and this is going to be our supply price. So this point here we have 100 PS is equal to 900 minus 100 PS, or PS is equal to 4.5. All right, and PS is equal to 4.5. We know that demand is 1 plus PS, so PD is equal to 5.5. Okay, and again, we're to find this is where this consumer, right, or the consumer are purchasing this amount, the producer is purchasing this amount. They're receiving and paying different prices, but the difference between them should be the value of the tax. And we just need to figure out then what this amount is, right? Well, we can plug in either PS into the demand curve or the supply curve, or we can plug in PD into the demand curve. So plugging PS into the supply curve, we get QS is equal to 100 times 4.5, which is equal to 450. Or we can plug, let's say, PD into the demand curve, right, which is 1,000 minus 100 times 5.5, which is also equal to 450, right? They should give you the same answers. And so the new quantity demand, the new quantity consumed, right, is 450. Okay. So we've found the new price and quantity. Now let's find, producer surplus, consumer surplus, tax revenue, and deadweight loss. So to find consumer surplus, right? What we want to do, right, is let's put ourselves back in the shoes of the consumer and realize that the consumer is paying the demand price. So this, I think, always sort of trips students up. Like, this is a little bit weird that we're now going back here. But the idea is the consumer is paying the demand price, and this is their demand curve, right, with the demand price, okay, PD. And so we want to find this area here as consumer surplus, okay? So what is this area? Right, well, we found in the last lecture that the p-intercept is 10, and that's not changing. So the base, or the height of this triangle, right, is 10 minus 5.5. Which is equal to 4.5. And then the base of this triangle is equal to 450, right? And so 1/2 base times height is 1012.5. And then to find producer surplus, it's the same thing as before. We just want to find this area here. So producer surplus, again, we know that the base of this triangle is 450. The height of this triangle is 4.5. So producer surplus is equal to 1/2 times 4.5 times 450, or again, 1012.5. The tax revenue, let me see if I have a different color. Tax revenue is the dollar for each unit sold times the quantity sold. I'm going to do this more generally using a T. So in this case, it is 1 times 450, which is equal to just 450. And then finally, to get deadweight loss, and then finally, to get deadweight loss, there are two ways to do this. So one way is we could just figure out the height of or the area of this triangle just directly, because we can figure out what the base and the height are. The other way is we can use our old consumer and producer surplus measures to get the area of this triangle and then subtract the area of this shape here. I'm just going to find the area of this smaller triangle here. So this is the deadweight loss. And let me draw in the tax revenue while I'm at it. So in this case, the deadweight loss so we have a base that goes from 500 to 450. So a base of 50 times a height of 1, right? 5.5 minus 4.5. Times 1/2. So the deadweight loss should be 1 times 50, 25. Okay, so notice, right, in this problem, right, the government imposes a tax, the quantity falls by 50 units, all right? So the consumer loses some surplus, right, because the price goes up. The producer loses some surplus because their quantity, the price goes down for them, right? So the consumer loses 50 cents on each of their 450 units that they still purchase. Right, the producer loses 50 cents on each of the 450 units that they still sell, right? And then both the consumer and the producer lose some surplus on the 50 units that they no longer trade, where there would have been positive surplus if the tax hadn't been imposed. So now I'm going to go through the solutions to handout H09, effects of a tax. If you haven't done this already, you might want to pause the lecture and work through it yourself. But both the with and without solutions handout is posted. So all right, so pause now. If not, I'm going to start going through it. So we have a cost function for an individual firm of C is equal to 500 plus Q squared over 30. And we want to find the supply function for an individual firm. All right, well, how do we find the supply function for the individual firm? Well, what we're going to do is we're going to write down the profit function. Pi Q is equal to revenue minus costs. For perfect competition, revenue is always P times Q, right, minus the cost function, which is just 500 minus Q squared over 30. Okay, then we're going to take the first order condition. So taking the derivative of the profit function with respect to Q is going to give P minus, there's no Q here, so just 2Q over 30. And we're going to set that equal to 0, right? Because what we're doing, we're taking the first order condition, is setting the slope of the profit function equal to 0, because that's maximizing the profit. And then we're just going to solve for Q. So QS of P is equal to, so we're going to add Q over 30 to both sides, 2Q over 30 to both sides. And then this is basically 1 over 15. And so multiplying both sides by 15, we're going to get Q is equal to 15P. Okay. So then if there are 20 firms for question 2, right, if there are 20 firms, what is aggregate supply? So 20 firms, aggregate supply is just 20 firms times the supply from each firm, which is equal to 300p. All right. So then it says, so aggregate demand is 2000 minus 200p, right? And then it asks us to find the short run equilibrium price, equilibrium quantity, the amount each firm produces, and each firm's profit. So one, to find the equilibrium price, so we're just going to set supply equal to demand. So this is 2000 minus 200p is equal to 300p. And then adding 200p to both sides, we're going to get 2000 is equal to 500p, or p star is equal to 4. Plugging 4 into here would give us a quantity of, into the supply curve, would give us a quantity of 1200. Plugging 4 into the demand curve gives us a quantity of 1200. I'm just going to write down the one for the supply curve, but you could do this either way. Okay. So then, let me see. So how much does each firm produce? Well, we have 20 firms, and they're producing in aggregate 1,200 units. So we can just divide. So QS is equal to 1,200 divided by 20, right? Or 60 units. We could also plug, we know each firm's individual supply curve, right? 15 times P, we know that the price is 4. And so we could also plug in 4 here and get 60 units as well. Either way works. Okay. So I'm gonna change pages. So if you need to keep writing, you might want to pause the video for a second. Yeah. So the next thing that it asks for is, let's find each firm's profits. All right, so profit is just P times Q minus the cost function, which in this case is 500, minus Q squared over 30. In this case, we just need to plug in things that we know, right? So now we know that each firm, that the price is 4, and each firm produces 60 units. And then again, each firm produces 60 units. So this, once we sort of go through and do all the math on this, this would be negative 380. Again, so this this has been the case quite a bit, but in the short run, this firm has been is not profitable. But again, its revenue 240, right, is higher than its variable cost, which is 120, and so this firm should continue to produce. Okay, so then part 4. Find consumer and producer surplus. So here, I always find it easier just to draw triangles, even if they're not very much to scale. So let me see. So I always draw the same picture, sort of regardless of what the supply and demand curve is, so long as the supply curve is coming out from the origin. So here we have a supply curve, QS of P is equal to 300 P. And we have a demand curve. This is just from the last page. QDP is equal to 2000 minus 200P. Right, and then what we found on the last page is that the quantity supplied was 1200, and the quantity demand, the price was 4. Okay, so to find consumer surplus, right, we need the area of this triangle here. So CS, so we need to find. So we know that the base is 1200. We need to find this point here, which is the point where quantity demanded is 0. What price is that the case, right? That's our p-intercept. Let me label my axes. And so to do that, we're just going to set QD equal to 0. And we're going to get 0 is equal to 2000 minus 200p. Okay, so that should give a p-intercept of 10. And that tells us then that the base of the triangle is 1200. The height of the triangle is 10 minus 4, which is 6. And then because this is a triangle, it's 1/2 times base times height. And so consumer surplus here is 3600. Okay. For producer surplus, we want to find the area of this triangle here. So again, what we need to do is find the p-intercept. What is the quantity? What is the price when quantity sold is 0? In this case, that price is 0. Right, just plugging in here. So for producer surplus, we know that the base of the triangle is 1200. The height of the triangle is 4 minus 0, or 4, times 1/2, right? 1/2 base times height. And so producer surplus is equal to 2400. All right. So now what we're going to have is that the government is going to impose a $2.50 tax. And we want to find the new short-run equilibrium price and quantity. then consumer and producer surplus, and tax revenue, deadweight loss. Okay, so I'm going to draw out the same graph as before, and then we'll sort of see how I shift things around. Okay, so all right. So first, the way that I like to think about taxes, right, like I said in the lecture, is that we're going to think about there being a demand price, which is, in this case, $2.50 higher than the supply price. Right, so PD is equal to PS plus 2.5. Okay, and then we want to think about, well, what happens to supply and demand? Well, the supply function, at least the way that I've done it, does not change because of the tax if we use the supply price. So this is just going to be 300 PS. And we're going to think of everything for a second as just being as a function of PS. So our demand curve, so our demand curve as a function of PD is 2000 minus 200 PD, which we could think of as being equal to 2000 minus 200 PS plus 2.5. 200 times 2.5 is 500. So we could rewrite this in terms of PS as 1500 minus 200 PS. Okay, and what that does is that just shifts down the demand curve to something, let's say, like this. Okay, so then to find the price, we're just going to set quantity supply equal to quantity demand, but both as a function of PS. So 300 PS is equal to 1500 minus 200 PS. So this is 500 PS is equal to 1500, or PS is equal to 3. And that's exactly what we see here. Quantity supply equals quantity demanded as a function of PS. PS is equal to 3. All right. Now, if the price of PS, the supply price is equal to 3, right, the demand price has to be $2.50 higher than that. So the demand price is equal to 5.5. Okay. So then, right, that's what we see here. So then let's find the quantity for each firm, or sorry, for the aggregate market. So plugging in 3 to the supply curve, right? 3 times 300 is equal to 900. Right, we could also plug in 5.5 into the demand price. Right, 2,000 minus 200 times 5.5 is 2,000 minus 1,100, right, which is equal to 900. So either way, right, aggregate supply is now 900. Okay, so then we want to find consumer and producer surplus. So for this, I like to go back and let's now just use for consumer surplus, let's use the consumers. Let's use the demand price for the consumer. So the consumer is now paying $5.50, right? And so, and that's the demand price, which is associated with this old demand line, right? And so we just want to find the area of this triangle here for consumer surplus. Okay, the height as before is 10. Okay, and so consumer surplus is equal, so we have a base now of, the new quantity here was 900, right? And so we have a base of 900 times height, which is 10 minus 5.5 times 1/2. Right, so this is 900 times 4.5 times 1/2, which is 2025 for producer surplus. We want to find the area of this triangle here. Which is, so again, the base here is 900, the height is 3, and so this is 900 times 3 times 1/2, which is equal to 1350. Okay, the tax revenue is this rectangle here, right, which has a height of 2.5, right? The government is getting $2.50 for each unit. And they're selling 900 units. And so the tax revenue here is $22.50, right? And then the deadweight loss is the area of this triangle here, all right, which has a height of 250, right? So the old quantity was 1,200. The new quantity is 900, so it has a base of 1,200 minus 900. And then 1/2, and so deadweight loss is 2.5 times 300 divided by 2, which is equal to 375. All right. And so I want to spend about 15 minutes talking maybe a little bit more about a macro topic, but talking, I guess, about roughly why sort of we think of perfect competition as being a good baseline for like welfare maximization. And the reason that I do this is just after talking about perfect competition, we're going to talk about other market structures, so monopoly, duopoly, and we're going to use perfect competition as a way of, as a baseline. So, you know, if we think about, you know, what is the loss of having a monopolist versus a perfectly competitive market, we just want to have a sense, you know, of how to quantify that. And so that's why I'm going to talk about sort of the reasons why Economists like perfect competition, but this is, this is a pretty rough um, lecture. So this is probably the first lecture that I'm like a little bit like hesitant to like put on tape. But that's so don't take this extremely seriously. But I just want to give sort of a rough outline for why we like perfect competition. Okay. So the last few examples that we did, in the handout or in the notes, showed that deadweight loss is a thing, or that we can have actual reductions in social surplus because the market isn't working perfectly, right? Consumers who have a willingness to pay higher than the marginal cost of production aren't able to purchase those products, right? So trades where positive surplus would be created didn't go through, okay? And so that at least gives us a baseline to say, hey, maybe it's possible that, under certain circumstances, we could do better, right? And so I think that raises the question of, how can we maximize social surplus? Right? And here, what economists like to do, just to kind of simplify the problem, is let's think about there being what we call a benevolent social planner. And let's think about, so this is, if, a world in which, either the government or some other, a king or something comes along and, decides how much every firm is going to purchase and how much every consumer is going to consume, right? And, under the best case scenario, they would be thinking about, how much, trying to maximize utility for each person and maximize profits for each firm. And so what they would do, right, is in theory, right, is they would choose the amount of each product so that the marginal benefit to society of that product being consumed equals the marginal social cost. All right. So the marginal benefit of a product being consumed is what the consumer gets from that utility, or from that product, which is the utility that they get. Right, and the marginal social cost is the cost of all of the inputs, or right, everything that they have to do to make that product, right, takes away resources that could be used to make other products, right? Or labor, which has some disutility, though we're not really studying labor models, right? The cost of all the inputs is basically the cost to society of producing that product, which someone is then going to use, right? And what the social planner would do, right, is they want to set, assuming the marginal social cost curve is increasing, as there's basically diminishing marginal returns to production, and the marginal social benefit curve is decreasing, right, as people diminishing marginal value. What the social planner would do, right, is by setting marginal social benefit equal to marginal social cost, they would find the point where these two are equal, right? Any amount of production before that point would have a positive social value. And anything afterwards, the marginal social cost is higher than the benefit, and so this would have a negative value. Okay, and just by looking at this, right, we can see in some sense, right, that this is matching exactly what the market does in equilibrium. Right. So the well, why is that, right? Well, if we think about what is the marginal social cost curve doing, right? Well, the marginal social cost curve is exactly the market supply curve. Right? Because the market supply curve, right, is telling us the marginal cost for each firm or for each product, right? So if that firm is going to produce another unit of output, right, it's doing it because its marginal cost is below the price, right? If we had some market price, right, it's producing until, right, its cost equals that price. But that's the same thing, right? Like we said before, the supply curve is equal to the marginal cost curve, right, for the firm. That would also be true then, like for just the social cost. If we think that the social cost is entirely made up of the cost to the firm, which we'll talk about that assumption later. Same thing for the marginal benefit curve. Is equal to basically the market demand curve. Right, so when I talked about consumer surplus, the idea is that at this point on the marginal benefit curve, right, this is measuring somebody's willingness to pay, right, which is also exactly what the market demand curve is telling us. Someone is willing to pay this amount for this unit on the margin, right, considering that they paid, if they were to have paid this amount for that unit. And so this, again, the marginal benefit curve is just telling us consumer valuation, right, but so is the market demand curve, okay? So this is basically a rough approximation to something known as the first welfare theorem, which you probably will see in either your macro or if you take a public economics class. All right, and the first welfare theorem says that under certain conditions, a perfectly competitive market results in an efficient allocation of resources. And therefore maximizes social surplus. All right, and this is like quite an amazing result, I think, because what it's saying, right, is that, we could think of a world in which we had this benevolent, social planner doing all of this work to figure out, right, what is the best allocation of resources. But if we think really carefully about like what that implies, right, that implies that somebody would have to choose, would have to figure out, what's the right amount of, good X for each person to consume for every possible good, good Y, whatever, like everything that you could purchase, right? What's the right amount of that for you to consume, and then assign that to you, right? And then also how much work you should be doing, how much labor and capital each firm should be purchasing. And, I mean, we've, simplified our models to have very easy, functional forms, only working with, two goods or two inputs and one output for each firm, right? But like these are all really, really strong simplifications, right? And this, social planner would have to do that for every single good, like for every single person for every day, right? And there's just like no way computationally that would even be possible, right? But instead, right, the idea is that the market, right, with everybody maximizing their own surplus or maximizing their own, every firm maximizing their own profit, right, is able to do that on their own. And that's, I think, sort of a rough distillation of sort of Adam Smith's invisible hand argument, right? That somehow the market is able to do this, even though it'd be very, very hard for a non-market entity to figure out this outcome. Okay. So let me talk for a minute about why this happens. So like what makes it so that the market is so efficient or is able to do such a good job of allocating resources? Right. And the idea here is that prices are basically the mechanism that provides the incentives for each actor in the market, consumers and firms, to produce the right, the socially optimal amount. Okay, so prices provide important information for each actor, either firms or individuals in the market. So if we think about first for like a consumer, right? They see a price at the store, right? And the price tells them basically the marginal cost of production. Right? With the idea, right, being that the marginal cost of, the marginal cost curve is equal to the, or the price is equal to marginal cost, right? And under perfect competition, right? So price tells the consumer, right, the marginal cost. And so each consumer then is purchasing until their willingness to pay, I'm just going to call this WTP, equals the marginal social cost. Right, and same with firms, right? When a firm sells, right, it's the price tells it the willingness to pay for the marginal consumer. Right, so a firm will produce until its marginal cost is equal to the marginal social benefit. Okay, so this is like, this is, I think, a really cool result, and it's a really, a highly sort of cited result for, why we should have free markets. I do want to point out, though, right, that in my definition of the first welfare theorem, right, we started off with the phrase "under certain conditions." Right. So it's not that this always has to be the case. In fact, this is, a very stylized and idealized result, right? It's rather that, under these conditions, prices will provide the information so that we get basically a maximizing, that, the market maximizes social surplus, which is something that we probably think, like a social planner couldn't do. However, it's not clear that these conditions always hold. So the first, so just to give a few examples of things that are going to break this down. So first, we're assuming perfect competition. So no firm or individual has market power. All right, so after the midterm, we're going to start thinking of models of like monopoly and duopoly, where firms have market power, in which case, the marginal, they're going to be selling at prices that are higher than marginal cost, right? In which case, the price is no longer going to be equal to the marginal cost of production, right? And so too little will be purchased. We might also worry about, externalities or transaction costs. Okay, so if there's like an externality, like producing output also creates pollution, right? Then we might not think that, say, like the marginal cost of production is equal to the marginal social cost, right? So that's an important assumption here, right? If, price equals marginal cost also means that, willingness to pay is equal to the marginal social cost. But if the marginal cost of production doesn't account for the fact that that firm has to pollute a lot in order to create that product, right, then maybe the marginal social cost is higher than the marginal cost of production. So that's an important assumption that we're missing here. This isn't going to be perfectly complete, but another assumption here is that actors have perfect information. Right, so I might not know before I buy something how much I'm going to like it, or I might not know, or firms might not know how well something is going to sell before they produce it. But that, would make it so that, if I don't know how much I'm going to like something, right, the price might not actually capture sort of the utility benefit that I get from that product. So my willingness to pay might be different than my marginal social benefit if I wind up, liking this product a lot more or a lot less than I thought that I would. And then finally, or another assumption here is markets are complete, which essentially says like we can purchase every asset. So there are times where no one is willing to sell certain products. One example might be like health insurance, where like we have the Affordable Care Act because in part there really was not a functioning individual market beforehand, right? So if you wanted to get health insurance and you didn't have an employer plan, right, it was very, very hard to get insurance because firms didn't want to sell that product. And so that would be a situation where we don't have a complete market for that product. But that again would make it very difficult. If people are willing to pay a high price for it, you still wouldn't see the marginal cost equal to the marginal benefit.